let's apply the cost capacity estimate method into problem 2. And for those of you in previous video, we talk about cost capacity estimate with the equation with different parameter, and we define those parameter in there. And now for problem 2, there are 3 scenarios. The first one is if a 10 million gallon water treatment plant costs $75 million, how much would a 25 million gallon plant cost? That poorly applied the cost capacity approach in here. So the equation C equal to Cn Q over Qn power m, and this is a water treatment. So we have that one here, you see. And the question asks is what is C for 25 million gallon per day. So we have that is C 25 per day. It equal to the reference facility C 10 million gallon per day times the Q of the new facility divided by the Q of the reference facility power m. And we need to find out what is this C for 10 million gallon per day. It already given, and then we just plug in the number there. So the cost for 25 million gallon per day is equal to 75 million times the capacity of the new facility 25 divide the capacity of the reference facility 10 million gallon per day power m. Keyword is water treatment. So go to the reference water treatment cost exponent 0.67 and the range 1 to 100 million gallon per day. Our project, the reference 10 million gallon per day. The new water treatment 25 million gallon per day. It's in that range, so we can get the exponent here equal to 0.67, and that should be in slide 10. So I can have that is slide number 10. So that to get m, you have that here in the table, and from that we can get that project $138.6 million. So to build the project of 25 million gallon per day, you just not time 25 divided by 100. It need to have the cost exponent or cost capacity factor 0.67 power in the ratio of the capacity of the new and reference facility. Keep that in mind. Now go to B. Scenario B. If a 10 million gallon per day plant above was built in March 13, how much would it be for the 25 million gallon per day plant built in July 18 costs? Remember the index that we use? So yes, we need to adjust for the time differences, consider the inflation, and that go back to problem 1 we did earlier, and that is also the index for March 13 and year the July 2018. So we can use that index exactly from the ENR to apply for engineering news record that you saw in the slides. And for those of you not familiar, go to video for lesson 1. So for problem 1, you can have that. So here, what is the question asked? Determine the cost of 25 million gallon per day water treatment plant built in July 2018. And with that, we can know what is the cost of the 25 million. Have to be the same project, same capacity built in March 2013, and we have the index for July 2018 divided by index for March 2013. And we already have that number. We can plug in. Here. 138.6 million times the index 11,116.42 divided by 9,000 for index for March 13, 456, and that we will get 163 million answer. So last one, would the 10 million gallon plant boat was built in March 13 in Santa Rosa, California. How much would the 25 million gallon plant built in July 2018 cost in Tallahassee, Florida? So you can see we have to combine the time adjustment and location adjustment. So we need to have index, some kind of location adjustment for the Santa Rosa, California, and Tallahassee. And that reference for the location factors also available on the exam 1 reference. And let's do that here for C. So we want to find out what is the cost of the 25 million gallon per day built in Florida, Tallahassee, Florida, on July 2018. So it have to be the same if that project built 25 million gallon per day built in Santa Rosa, California in July 2018. And of course, with that, we have to time the index, location index of the Tallahassee. That is where the new facility going to build. And we have to divide the index for the location at Santa Rosa. So how to get that information? You can have that here in, let's write down, and then we go to the reference for the location. So see in here, 25 million gallon per day, Florida, and July, Florida, I mean Tallahassee. Here, for 25 million gallon per day built in Santa Rosa in July 2018, that is 163 million. 163 million we did in problem B. And then the location factor that we need to do for the Tallahassee and Santa Rosa. So go back to the reference. That is location factor that you see. And that is Santa Rosa. For commercial, in this case, the water treatment plant commercial, the factor is 1.13. For the Tallahassee, it's 0.8. What does that mean? As you can see, if you build the project in Florida, it tends to be cheaper, much cheaper, maybe 30% cheaper, as you can see there. So we have to accommodate for the location factor, moving the project from Santa Rosa 1.13 to Tallahassee 0.8 for location factor. Again, this reference available on Canvas and on the exam reference. So from that we can have here Tallahassee is 0.80 and that is 1.13, and that you go to a slide, very last slide, so slide number 11 to get that reference. So from that we get the 25 million gallon per day Florida, July 2018 in Tallahassee. The cost is cheaper, 115.4 million. So for this one, this problem, we combined the cost capacity and then move on to adjust for the time in B and adjust for the location in C. And in the next concept, we combine all of this to make a holistic view and do one last problem.